Assalamu alaikum. I'm Farrukh Nadeem with an Aspire tutorial. The Aspire series is about rotary. Today, I will show a new rotary technique. If you get a 3D design from another software, I will show how to bring it into Aspire, tool it, and cut it. How much length you need for this in this pose, I am setting its length to 24 inches here. I have kept its diameter at 5 inches, and the Z0 position is set to the center. As for its direction, the X or Y datum direction, set it according to whichever side your machine allows. Set the orientation according to your machine's orientation, and then click OK. After clicking OK, you need to go to the model. Placed a three-dimensional model right here in the scene, and as soon as I import it here into the workspace, it will take a little bit of time to import, just a short moment. After that, it will be imported here successfully. Take a look. This is the component that we just imported into our project. Actually, it was a pillar that we created earlier, and now we have imported it here for demonstration purposes. See, I am orbiting around it because this particular file is quite heavy and complex, so it's running a bit slow and may take some time to respond. As I am orbiting it right now, the process is a bit slow. Here, the very first feature we have is the imported model type. You need to set it as a full 3D model because the pillar we want to make requires the complete model to be imported and cut as it is. If you didn't want to wrap it around, then you would use the flat model option. Now, in its initial orientation, if I, for example, move it to the right, its positions will change here. We don't need these. If you do it, look, if I move it to the bottom here, it will completely flip it upside down. Anyway, for now, we'll keep it at the top. Besides that, if you want to manage its different rotations, for example, if I set it to 0 degrees, it will completely change its direction, meaning the diameter will become larger, and it will be ready in this form. So we need to set it to 90 degrees. Rotate. If we keep it at positive, it will only change its direction. Just like you saw here, its direction. If you keep it on positive, it will only change its direction. Just like you saw here, it changed its direction. That's why, for now, we don't need to change them. After that, there's interactive rotation. In the same way, it creates rotation between the view and the model. Now, if we come to model scaling, this is the most important thing that you absolutely have to manage. How is that? It's like this. Since it was very large. The model was even bigger than 52 inches. So now what we're going to do is the diameter on this side, that is, its diameter was 52 and its length was 209 inches. It was very big. The model was even larger than 52 inches. Now, the diameter on this side was 52 inches and its length was 209 inches. The file was in millimeters, converted to inches. Here, I set the diameter to 5 inches and the other side automatically changed to 19 inches. The model is now currently set according to that. Look here. If you want to, right now, the model is now set according to that. Look here, if you want to increase its length here, then you'll need to uncheck the lock ratio, and here you can set it to 24 inches. That means now the model will be set according to this. The second option is that you can select Scale Model to Fit Material, and it will automatically fit the model into the material. What we entered manually here, it will do that automatically for you without you needing to take any extra steps. So the resizing we just did, let me be clear, I personally would never recommend that you do this kind of resizing manually. Always set the size using the ratio. That way, the design's beauty and proportions won't be ruined or compromised. But I had to show you this method for demonstration purposes, so that's why I demonstrated it just now, to make sure you understand the process. So, as you can see, our file is now ready for tooling and further processing. Here, if I select its double window, you can see here, this is our 2D file, and here is our 3D file. You can also orbit around it to view it here. It takes a little time to render, because on some systems it might take even longer, but once it's rendered, it will show you a preview. Now, the things on the inside are cut out using a fine tool, but since I just put in a random design to show you guys, when you do it, the design tool, these things are really important to manage. Usually when our people are working in 3D here, they're always looking for ways to save time. I mean, I see it all the time, even in the group where you guys share things. People get caught up in trying to save time. And look, saving time is definitely important because it affects your cost. How much time you spend on it is directly related to your cost. So, what is it giving you in terms of cost? These things are all interconnected, but while being quality conscious, customers will come and go over time, but the consistent quality of your work is what will truly stand out in the long run and help your business continue to grow and succeed. So, always try to save time whenever possible while also maintaining the high quality of your work. And make sure to charge your customers enough so that you actually benefit and your efforts are rewarded. Normally, what happens in our market here is that people use a motor tool, that is, a ball nose tool. The ball nose is basically used for three dimensions. So, the thing to understand here is that if you use a ball nose of one suit, then the design's fine details can't be more than that suit. So, try to use a finer ball nose for work where you want good quality. Like, I recommend using up to 1.5 millimeters. Sometimes we even have to use a ball nose up to 1.75 millimeters. So, go ahead and do that if needed. But also make sure to charge the customer accordingly for this level of work. If they're paying for it, you must deliver quality work. Your machine will keep running, no problem. When the customer pays you, make sure to offer this to those customers who are quality conscious. So, what I'm trying to say is that tool selection depends on your design. If the design is very fine, select the tool accordingly. If the design is a bit bigger or thicker, then choose the tool for that. Here, a 1 millimeter tool isn't suitable. Tool choice depends on the design's fineness, especially the corners. For bigger designs, use a bigger tool. For smaller ones, use a smaller tool. Let's begin tooling. First, we have 3D roughing. Select the half-inch tool, set the machining allowance to 0.04, and choose either raster or Z-level for the operation. We usually use raster. We do it like this and let it calculate. It'll take a little time for the calculation. Here, the pass step is very important. You should set the pass step at least equal to the tool size. I set it to 0.5 because wood is a soft material. Here, we have to go a little out of the way with the pass step, so I set it higher. Then let it calculate. It'll take a little time for processing. Once the calculation is complete, you'll see that the roughing program has been created here. So I'll preview it now. Here, look at this. It has given us a preview. Select it, reset it once, and preview the visible toolpath again. So look here, 1, 2, 3, 4, 5. It took a total of 5 steps and created this shape. Since we used a half-inch tool, as soon as this process is complete, you need to generate a new toolpath here, the 3D finishing toolpath. Use a 1/8 ball nose, set the boundary, choose raster, and calculate. This will take time. Is about to be generated. So, viewers, as you can see here, it has also generated the toolpath for the 3D finish. Now, if we close this, we have the entire situation here. I'll switch it to double window here, and you can see that both toolpaths have been applied. If I uncheck the finish, this is the condition. If I uncheck the rough, this is the condition. So, if you uncheck both, this is what we have. If I do this, first of all, you can clearly see that the three-dimensional roughing process has been completed, and on the preview of the visible toolpath, it has performed the roughing operation in 5 distinct steps. After that, if I select this finishing tool and preview the visible toolpath once again, now it will proceed to do the three-dimensional finishing on top of the previously roughed surface. See, it has now completed the three-dimensional finishing process over the roughing, and at this point, we can also begin to see its final preview, which gives us a much clearer idea of the completed work. After that, you all are already familiar with these things, that you have to save the file. In the selected toolpath, I first select the roughing and save it here. After that, you have to do the 3D finish and save that as well, because we have to do both tools separately since both tools are different. If you have an ATC machine, you can select both tools together and make a single program. But since usually people don't have an ATC, I've explained both scenarios to you. Viewers, I hope today's session will be very beneficial for you. It was something new. We imported a 3D model onto the rotary and then did the cutting as well. God willing, I will be back again with a new technique next time. Please allow me to take my leave. Remember me in your prayers. Allah Hafiz.